manufacture of Brunswick tires, each cord is drawn from its individual spool. Guided by thousands of tiny eyelets, the cords are carried through a specially conditioned room where the temperature and moisture are strictly maintained to preserve full strength and elasticity of the cords. The manufacture and processing of the insulated cord construction is far more costly than the processing of ordinary pick fabric. Here, each cord must be held in positive position until it passes through huge calendars and formed into a wide sheet of ply stock containing 1,800 cords, thoroughly and evenly coated with a special rubber compound. The rubber used for this ply stock is so compounded that it possesses high anti-friction properties, which give further protection against internal friction and wear. The angle of the cords in the ply stock is an important factor in the life of the tire, because a definite angle is necessary to give proper balance to the body plies. In order to assure the correct angle and exact width of the plies, this enormous cutting machine is used. Accurate to a fraction of an inch, the strips are carried to the tire room individually on an immense system of conveyors. Another important part of a tire is the bead. The wire used has a breaking strength of 280,000 pounds per square inch. Each strand is thoroughly insulated with a special rubber compound, then automatically formed into a circular band. The spliced ends are taped, and on another machine are covered with a special rubberized fabric. This fabric covering is called the flipper. It's used to anchor the bead to the body of the tire. Another long, safe mileage feature of Brunswick tires is its famous safe and efficient tread. In order to produce this tough, wear-resisting tread stock, 7 different ingredients are blended in with the highest grade of raw rubber obtainable. Each ingredient is accurately weighed before it is mixed in the huge Banbury mixing machines. These machines mix 800 pounds at a time, and then dump the batch to a conveyor belt which carries it to a series of large cylindrical rolls called mills for further mixing with additional compounds. These mills not only mix the rubber, but knead it as well, much as bread dough is kneaded before baking. Another mill heats and prepares the stock, cutting it into a large, thick, continuous ribbon before it is fed into a machine which forms it into proper shape in width and thickness. Here it begins to look something like a tire tread as it travels along a 300-foot conveyor to be cooled, weighed, and checked. A special compound of adhesion gum is next applied and thoroughly rolled onto the underside of the raw tread strip. This layer later becomes a part of the double shock absorber unit, which provides the positive adhesion between the tread and the carcass. At the end of this long conveyor is an automatic cutting machine, which measures out and cuts the tread stock into the exact length required for different sized tires. Further check, however, is made on the weight of each strip of tread stock to assure proper balance to the tire. If the weight is off a fraction of an ounce, the strip is rejected. In the tire building room, the components are assembled. Plies, beads, flippers, tread stock, finishing strips, and double shock absorber units made ready for tire builders. Skillful operators with years of training and with equipment of the most modern type. This cylindrically shaped machine is called a drum. Each ply is rolled accurately and smoothly into place, one ply at a time. A system of rollers shape the plies to the drum and press out all air pockets between the plies in order to produce positive union of all parts of each ply. After the second ply is rolled down, the beads are placed on each side. The flipper strips surrounding the beads are securely fastened to the edges of this second ply, and the edges of the body fabric are lapped over the beads, locking them firmly into the body of the tire. The additional plies of cord fabric are then added one by one until the carcass is completely built up and prepared for the tread stock. One of the most common causes of premature tire failures and blowouts is the separation of the carcass from the tread. In order to eliminate this hazard, Brunswick has developed the double shock absorber unit. That's the center unit being applied. It consists of 2 extra layers of cord material treated and coated with a special cushion compound, which not only ensures positive adhesion of carcass and tread, but also protects the body of the tire from high-speed road shocks by absorbing and distributing them over a wide area of carcass. Double shock absorber is an exclusive Brunswick feature and found only in Brunswick Super Service tires. The 2 black strips at the sides are chafing strips. They protect the lower sidewalls of the tire from rim chafing and keep the flexing action of the sidewalls evenly distributed above the point of rim contact. The thick, tough tread stock is next placed smoothly and evenly over the entire carcass, the ends spliced securely together. It is rolled firmly and pressed to the carcass by the rollers at the bottom of the drum. When it's removed from the building drum, it's in the form of a hollow cylinder. Doesn't actually look like a tire until it's shaped in the forming box. Now here the tire is prepared for the mold. A heavy rubber tube called a water bag is placed inside the assembled tire in the forming box. A quick application of heat, and the tire is shaped to fit the curing molds. In the curing of a tire, heat and pressure should be applied uniformly to the inside as well as the outside of the tire. Otherwise, the rubber coating of the inner plies would be of a different consistency than the rubber of the outer plies. With the Brunswick hydro curing process, the tire receives a thorough, even cure throughout. Because after the tire is placed into the mold and the top half of the mold clamped down, it's lowered into a huge boiler or vulcanizer, and a fitting is attached to the water bag inside the tire. 28 molds are placed in each vulcanizer, each mold fitted with a water connection. A hydraulic ram gradually lowers the molds as they're placed. The water fittings interlock, forming a pipeline. When the vulcanizer is closed, water at a temperature of 300 degrees Fahrenheit and at a pressure of 240 pounds to the square inch is forced in the water bags inside the tires. At the same time, steam temperature of 300 degrees Fahrenheit is applied to the outside of the molds in the vulcanizer. The temperature and pressure of the water in the water bags, the steam in the vulcanizer, the hydraulic pressure on the ram, and the curing time are all accurately controlled from one central point by automatic regulation. The slow baking process gives an even cure throughout the tire and induces full adhesion of carcass and tread, not obtained where air is used in the bag, and the curing is done from the outside of the molds alone. As soon as the tires are cured, they're cooled by flushing the molds with cold water to prevent any possibility of over-curing. Removed from the vulcanizers to a long conveyor system. The molds are cracked open and the tires removed. In the finishing room, they're sprayed with tire paint, trademarked, striped, and balanced, then put through a rigid inspection test. In spite of the thoroughness, the constant check during each phase of manufacture, every tire is thoroughly inspected inside and out. No blemish or imperfection is overlooked. Every tire must check with the exacting specification set for it. Specification set by one of the most outstanding groups of research engineers and chemists in the industry.